Good morning, ladies and gentlemen. My name is Mosiari Margaret. I'm the subject advisor for natural science in Fezile Dabi, and I'm responsible for natural science in grade 8 and 9. And our topic today will be energy and the national electricity grid, which is a grade 9 content, and then it is for term 3. So I'm just starting with explaining what is energy. Energy is the ability to do work. And we are going to explain what is a national electricity grid. Because remember, if you don't have energy, it means you cannot be able to run, you cannot be able to work, you cannot be able to do anything. So that is the ability to do work. And then let's look at the national electricity grid, and then we are going to explain it. The national electricity grid is a system that helps to deliver electricity around the country. Each and every household, they need electricity in order to cook, in order to do daily duties. And also the industries, they also need electricity in order to perform certain duties at the industry. And then the national grid connects energy sources to our homes, ensuring electricity flows smoothly into our daily lives. So that is the function of the national electricity grid. And we are going to look at the role of the national grid. It is to make sure that electricity reaches homes and businesses from where it is produced, and enable the transition to a clean energy system. And where is this electricity generated from in South Africa? Where do we get this electricity, or is it generated? In South Africa, electricity is generated from coal, wind, ocean waves, falling water, and solar. It means these are the things that electricity is generated from. Most power stations in South Africa use coal to produce electricity. Coal is one of the unsustainable natural resource. So coal, it is a natural resource, but it is unsustainable, meaning it will be depleted. It means at some point, there will not be any coal in South Africa. And this is a picture of a power station. As you can see, there are so many towers here, and there is also smoke. There's a lot of work that is happening in those in that power station. And then let's look at generation of electricity at a power station. In South Africa, to generate electricity, most power stations use coal as a source of energy. So there are few of them that don't use coal, but most of them are using coal. Coal is first crushed into fine powder. It means they are going to crush it to make it. Remember, coal, it comes in a large lumps. So it comes as lumps that are so big. So it needs to be crushed into powder, which increases the surface area and allows it to burn more quickly like gas, because gas, when you start to ignite it, and then it started burning. So that's why it is crushed into powder. The powdered coal is then placed inside a furnace where it is burned at a high temperature. And the heat energy produced inside the furnace convert the water in the boiler into steam. And a furnace is where fuel burns to heat water so that it can turn into steam that turns the turbine. So it means inside a furnace, then we have a fire, or we can say we have heat that has a very, very high temperature. Remember, that heat is going to make sure that the water is boiling, because we don't need water, we need what we called the steam. And then in order to get steam, it means the water should boil. So the furnace is where fuel burns to heat water so that it can into steam that turns the turbine. The steam in the boiler pushes the blades of the turbine to rotate or to turn at a high speed. And the blades of the turbines spins, turns, or rotate the generator, which contains magnets and coils. The spinning turbines is connected to a generator. The generator generates electricity, which is mechanical or kinetic energy, to electrical or potential energy. The steam is condensed back to water in the cooling towers. The process is repeated. It means it is going on and on and on and on. The current is then sent to the transformers. The transformers steps up the voltage for transmission. Folks, I know that when I'm saying all of this and then you get confused, but I'll explain them in a nicer way later when we go on. The grid takes generated electricity to substations and then to our houses through the power lines. Before electrical power enters our homes or the factories, the step-down transformers decreases it to 230 degrees, which can be used inside our houses. So this is a pile of coal that needs to be crushed. And then after it is crushed, it is taken into the furnace. So inside the furnace, that there is heat or there is fire that is going to make sure that the water inside the tubes, and then it means the water boils and then it is going to form steam. And then this whole thing, it is a power station where the whole process is taking place. After the furnace has boiled the water into the boiler, and then that steam is going to turn the turbines. So those turbines are going to turn the generator and then make sure that the generator generates electricity. And then that electricity, when it is made, it goes into the transformers. But here it is at a high voltage. And then we have the national transmission lines. So these big lines, they are called the national transmission lines. So they transmit electricity from the power station to the substations. Here at the substations, then we have what we call a step-down transformer. It means it's going to make sure that that electricity that comes from the power station, it is now decreased to a lower voltage so that it can be sent into our houses, the shops, and other buildings, as you can see in that picture. And then let's look at what I've been explaining. And then we have coal here. And then this is a chimney for smoke. And then we have what you called a, what we call here, this is a conveying belt. And then it transports this coal into the pulverizer. And then it goes into the furnace. This is a furnace. As you can see, there is fire here. It means the temperature inside the furnace, it is very, very high. And then from there, we have a boiler where we have water inside here. Inside these pipes, there is steam. It means the water has boiled inside this boiler, and then the water now has turned into steam, and then it moves into the turbines. So this is the turbine. As you can look at this picture here, we have some shiny things. Those are the blades of the turbines. And then the steam is going to cause the blades of the turbines to turn. because these blades are connected to the generator, or the generator is connected to the turbines. When the wheels or the blades, not the wheels actually, it is the blades of the turbines, when they turn, they are going to make also the generator to turn, because both of them are connected. And when the generator turns, that is when electricity is connected. And then it goes into the transformer, and then into those big transmitting lines. But here, the voltage of this electricity is very high. And then that water now is going to cool down. And then it means we have that process of condensation. And then it is now the steam cools down, and then it becomes water. And then the water goes again into the furnace, and then goes to the water goes to the boiler. And then remember, we have a furnace that is there that has coal to make fire, that makes the water to boil into steam. So it means this whole process is going to be steam, and then go to the turbines to turn the turbines in order to turn the generator, because the generator and the turbine, they are connected. And then the generator turns to make electricity. But that water or the steam, it doesn't go lost. It is not lost. It means the steam will go into a condenser, and then the condenser is going to cool the steam, and then the steam is going to turn again into water, and then back to the boiler, and then from the boiler, the steam again. So this is how the water is going to recycle around the boiler. And then from the boiler, it is steam, and then from the steam, it is the turbine, and then the turbine, they turn, the blades of the turbine turn because of the steam, and then from there, the blades of the turbines, they turn the generator, because both the turbine and the generator are connected. So it means the whole process, it is recycled over and over and over again. That is how electricity is generated. So it means after electricity is generated, and then it moves from here at a power station, and then it goes to the transformer. But the voltage here is very, very high. And then from the voltage, it goes into this national transmission lines. It moves through the lines into the substation. From the substation, here we have a step-up transformer. Here we have a step-down transformer. It means that transformer here, the voltage is very high, because it needs to move long distances to the different substation. And then when it reaches those substation, then that is when it's going to be made to be transmitted to our house, and then it is decreased to be 230 volts, and then it goes to our houses. Here are the houses, it goes to the shops, it goes to other buildings or the factories where it is needed. So thank you very much for listening, and enjoy the rest of your Heritage Day tomorrow. Thank you, colleagues. Bye-bye.